So the next speaker is Peter Phillimore from Australia. Are you ready, Peter? Okay, he's going to be talking about pawning this NFC.
Okay, so thank you for waiting. I'm just setting up a heap of equipment at the moment, so I'll make sure I'm going through it as quick as possible. Okay, so today I'm talking about NFC cards and more specifically around NFC payments. So, quick about me, that's stuff there. I'm going to skip that because I've got too much stuff to talk about. Okay, so for this talk I'm going to assume you know the low-level NFC stuff. So I'm not going to go through the initialization, how cards work, all that kind of stuff that really don't need to know for this stuff. Going to assume you know crypto stuff, how really simple cloning of cards are done, and all that kind of thing. So quickly, this is just a list of definitions. I'm going to leave this in the slide deck more for later on so people can read it and actually understand what I'm talking about and generally some of the definitions used in NFC payments. The key ones to look at are specifically the ATC, which is Application Transaction Counter. So that's a counter of the transactions performed on a card. So this is an EMV tag which tells you how many transactions a card has done for its life. So you get a maximum of 65,000 or so transactions, and that's just a counter that keeps counting each time you perform a successful transaction. There's the unpredictable number. So this is supposed to be a random number, can be a date, for example, in the standard, so it's not really the greatest unpredictable number, but that's used in a transaction in the authentication process normally. And the other key one is the Cvv codes. So these are your card verification values. These typically are used for prevention of alteration of data on a card originally, and have been extended to prevent cloning of cards as well, now in contactless transactions. Okay, so a quick overview of an NFC payment. So here I'm skipping over the initialization steps for a card. So at this point, the reader knows what kind of card it's talking to and has set up all the transaction timing stuff. So all cards in the NFC payment world do this typical first step of transactions. So here you're looking at the select PSE, which is a payment system environment. That's an entry just basically saying we are a banking card. So normally this is a to-pay DDF something. It's a fixed string that pretty much all cards, Visa, Mastercard, Amex, will use to identify that they're a banking card. The second step of the transaction is a select AID. Select AID is the application identifier. So this is where we're selecting what payment type to use. So normally this is where we're saying, okay, let's use Visa, let's use Mastercard. Most cards I've seen will only have one AID on them. So there's the ability to support multiple card types. However, they're normally one brand, one card only in practice. So after that step, we basically get sent back what is called a PDOL. A PDOL is a processing data options list. What this is the card telling the terminal, okay, well, what do we need to perform a successful transaction, basically. So it tells us what tags we need to generate the CVC codes or application cryptograms, for example. In Mastercard's case, this PDOL list is normally 0, so there's actually no tags required in this list. However, the Visa standard, you've got to send a number of different fields. So these normally amount to amounts, date of transaction, terminal unpredictable number in this field. But the same kind of structure is basically used between Mastercard, Visa, I think Amex as well, in that area. Okay, so on to the good stuff. So how do you clone a Visa card? So generally, just to point out, this information is only for educational use. There's a reason I'm not releasing all my tools because you can break cards doing this stuff. Also, you kind of mucks things up, and I don't want to get illegal mumbo jumbo with large companies, pretty much. Okay. So to start off with, Visa supports 4 basic modes of verification for a transaction in contactless. You've got dynamic CVV. This is the oldest mode. Simply put, it was implemented to try and prevent card cloning, and it was, I think, released around 2003 or 4. So this is the oldest mode. It's pretty terrible, and it's not even good, basically. You've got the updated version, which is cryptogram version number 17. So this is developed off Visa's EMV standards. Simply put, it's taking a few fields and doing an EMV transaction over it to generate what's called an application cryptogram. So it generates a proper token for authentication. You've got quick Visa Smart Debit Credit, which is a reduced EMV mode. Simply put, this is a cut-down version of EMV. So instead of doing all the certificate checking while the card's in the field, you're able to scan the card, take it out of the field, the terminal will do the rest of the work on the transaction, and you can go off. It's basically intended for speed. And the last one's the Visa Smart Debit Credit spec. This is, simply put, a full EMV mode. So this is doing what your normal card transaction does in a combined data authentication and terminal cryptogram authentication. So that's generally the best and most secure standard at the moment and prevents cloning. So secondly, how does a card and the terminal actually know what kind of mode to use? So in the PDOL list, we have what's called the TTQ, which is a terminal transaction qualifier. So this is how the terminal says this is what transaction we want to perform. So here I've ripped these out of the Visa docs, is the bit mapping of the TTQ. Simply put, the way we determine which modes to use, we flip certain bits in this bitmap, basically. So we're looking at, say, if we want an MSD transaction, for example, we'll flip the highest bit 1, and then just make sure that we're not flipping other bits for VSDC. If we say we want CVN'15 mode, we flip the high bit of the TTQ, and we also flip the requirement for an online cryptogram, which is in, I think, byte 2 high bit. So this is how a terminal tells a card what it supports. So generally, in a Visa transaction, the terminal has is able to tell us what it wants to support, and then the card's able to select how it wants to proceed as well. So in a Visa authentication flow in DCVV mode, we've got these steps here. So I've done all the initialization stuff. So we know we're using a Visa card, and we know what the terminal supports. So the next step is the terminal will send the get processing options command. This command, simply put, is where we just pack together all the field data as sent. So in this example, and most Visa cards, these are the standard tags you'll see. So you've got your terminal transaction qualifier, the amount, the unpredictable number, and a currency code. So the currency code just tells us what country we're in, for example. On a successful receipt of the PDOL, the card will then send back an AIP and an AFL. AIP is the application interchange profile. This is a set of 2 bytes where we're saying, okay, the card supports these modes. So this is where the card's saying, okay, I support EMV and I might support just static certs, for example. Or it'll send back an AIP where it's saying, yes, I'm a contactless card and I support EMV, basically. The AFL is the application file locator, and that is simply there for understanding what records we need to read to perform the transaction. So the way chip cards are generally structured is that you've got records of data in the card where you can ask for, say, a set, say, record SFI1, record number 1, and it'll spit card data back to you, say, track data, what else, issuer codes, that kind of thing. next step, basically we start reading records and we get track data off the card. Okay, so I'll show you how we clone a card. So let me flip over to the application I've created for this. So, just a second now. Okay, so here's my screen on my phone at the moment. So the application I created is basically using the latest Android APIs, which have enabled host card emulation. So with a Nexus 4, I think the latest Samsungs, you can read cards and you can emulate cards, which is awesome for this kind of stuff. So if I can get a card out. So here's a load and go Visa card. So these cards I got from a post office in Australia, so they're just a prepaid Visa card. And so to clone it, we just have to scan it. Which is hopefully. Now these cards are generally cheap, so they don't actually scan very well. Got it. Okay, so here you see I've added the card at the end. So I've basically just got the last 4 numbers to indicate what card it is. And this is the response given in terms of PSC stuff for logging. Now, if I quickly swap over to okay, so here I've got, you probably want to see that. So this is an application I developed just using RF idiot tools, which does a transaction using DCVV mode. So this does generally what the VivoTech here does, but I can at least print out all the values I'm getting from the transaction. So check the code, that one. Now I should. So here you see the transaction has occurred. That's with the real card. Now with the emulated card, which I'll have to unplug. So here you basically see the emulated card spits out the same data as the clone card. Alright, so I'll skip over basically a lot in terms of just trust us, it's the same track data that's being spat out as the card that I've just read. Now, the key thing with the Visa mode as well is that it's optional. DCVV is an optional algorithm. The issuer doesn't have to implement it. So in the example that I've actually got with this card, which is a prepaid card, the DCVV mode doesn't actually generate a unique CVV each time. So if I want to clone someone's card, for example, with this type of card in DCVV mode, this means I can basically go up, grab their card, and scan it and just keep using it. There's nothing to stop us from cloning this card, for example, like a traditional magstripe card. Additionally, I found a lot with the CVV stuff is that it basically they don't set it up properly, a lot of the issuers. So you see stuff like actual track names, for example, cardholder name on issued cards. So I've seen ANZ cards in Australia with a full, someone's full name on their contactless card. So that kind of opens up a lot more. It's a lot easier to skim cards, for example, for card not present fraud if you've got their name as well as their card number and valid values like that. So there's not really any policing of this stuff on the Mastercard Visa side of things. It's left all up to the issuing banks to do a lot of the setup of this stuff and ensuring that they're doing it correctly. And there's no real PCI mandates or anything around this stuff to tell them to do things correctly. So I will quickly show a transaction in CVN mode. So, now CVN. Okay, so CVN'17 mode, you can see there's a fair number of different fields that are spat out in this mode. So in CVN'17 mode, instead of using a CVV value that's embedded in the track data, we're using an application cryptogram. The application cryptogram is generally a lot better because it's taking a lot more values, encrypting them, and spitting out a long value as opposed to a short value that's intended for inserting into track data. The reason for DCVV mode and these older magstripe modes is that you require, in payment systems, you require backwards compatibility. So you need to be able to narrow it down to try to get the transaction through. So a huge amount of the payment systems, payment flow network, are built on old systems, old technologies that they keep having to support because it's so expensive to buy new stuff and implement new standards. And this is where you get these DCVV and these fallback flaws in systems in that area. So that was how to do a Visa card. It's a lot easier to do a Visa card than a Mastercard. However, in practice, I haven't been able to successfully do it in Australia. I'm hoping to perform one in Singapore because Australia it's a bit more difficult to do this kind of attack because the issuing banks are fairly good on actually implementing correct procedures. However, in other countries and when you cross borders, it's probably a lot easier to perform these kind of attacks. Okay, so cloning Mastercard. So on Mastercard, we support two different modes. We've got a magstripe mode and M-chip mode. For M-chip mode, that's basically our EMV mode, similar to the Visa standards. We're doing an EMV workflow again in this mode. However, we've got a magstripe mode in Mastercard, which is equivalent to your DCVV or your CVN'17 modes in Visa. So these are intended for fallback to support old legacy equipment. So on the Mastercard side for the NFC payments, magstripe modes perform a different flow after identifying that's a card. So instead of relying on the PDOL list, we actually use a function called compute cryptographic checksum. This is a command where we push in a terminal random number generated by the terminal to the contactless card, and that uses this combined with the 8TC, combined with the PAN, I think that's right, and generates the CVC codes to insert into the track data and send off to an issuer. So here we've got an example of a test where I've started out, and that's the CVV codes generated for unpredictable number. Testing this stuff and repeating it's difficult because you can't change the ATCs on a card. They're a built-in counter, so you can't go backwards in transactions. So you can't take a transaction and roll backwards, unfortunately. So you can't really check when testing is that the correct cryptogram without having the keys at the other end. So when I was testing, I was generally using live equipment at a retailer, for example. So let's see. Okay, so the way to clone a card in the Mastercard case is you scan the card from someone and you perform 10 to the length of the unpredictable number required transactions. You then can go with your Nexus 7 and then perform the attack. So now, how you actually determine the length of the UN is the issue here. The length of the UN normally is 4 bytes long. So you're looking at, 4 billion different values in theory. So if you look at the standard, you kind of read it and go, okay, great, that looks secure, skip over it. However, the issue is we've got to support old equipment, we've got to fit this into track data. So we're actually limited to the number of valid numbers you can use. So we format the CVV as a binary coded decimal value. And then the issuer has to limit the length of the CVV and the ATC and the unpredictable number to fit inside its track data for its system. So it's up to the issuer to actually set the length of the unpredictable number. So in this case, for Mastercard, you take 4 bytes of binary, so you got 4 billion values. But then we've got to knock it down because it's binary coded decimal, so we're still at 100 million, which is great. However, depending on who the issuer is, they will usually support from 2 to 4 numbers in length. So halve that, that's normally either, 1 byte or 2 bytes long. So in the case of, say, National Australia Bank and cards I currently have, it's only 100 values for an unpredictable number, as in 0 to 99 is the valid length for the random number in this case. So showing you how to clone it now. Okay, so now application. Okay, so take my second. Alright, thank you. So now this is a lot easier to clone because the card's a bit more high quality than the off-the-shelf unit. Okay, so to clone it, we. Okay, now so you see here we've spat out our log data, so I've cloned it fairly successfully. Now, try and do it again. See, this is a fun thing. That's better. Okay, so hopefully that's cloned correctly, and that's done. Okay. So we then play it back to terminal. So hopefully my laptop's not going to die on this side. Now, mouse. Don't die on me, laptop. Actually, I can't work it out before my laptop's going to die and I don't have time to plug it in. All right, anyway, just assume that worked. I can show it later anyway, if you're interested. Simply put, this works because we have, we only have a limit in terms of the amount of random numbers, meaning we just have to perform 100 transactions, record each correct Cvv code, and then when we go to a terminal, we can then look up what unpredictable number was sent to the card, then we can generate a correct CVC for that code. So I've actually done this in practice in Australia and performed successful cloning of my own card. Because most of the time there's a assumption that issuers are programming correct codes to the cards, and on the payment processing side, fraud detection is actually taking account of your ATC codes. So the way to protect this stuff is there's a number of different areas you can do it, but primarily you just need to monitor your ATC jumps. If you jump 10 or 20 transactions, there's a good chance that the card's been cloned and you can flag it. And all the other things here. So I'll skip over. Okay. So I've created an application to test for this on cards as well. So this is on my GitHub at the moment, so that you can scan in a card and it'll tell you how long a random number is, how long it'll take to clone, and generally give an idea of if your issuers are programming them correctly. So I've got cards which are 4 bytes long and cards which are 2 bytes long. And I've got a card which is 0, which is a prepaid card. So it really depends on what the issuer programs your card as. Okay, so I will quickly skip over to the end. You can annoy me about the tools, how to fail and break stuff properly. And so, in conclusion, hopefully I've shown that it's actually possible to clone cards in practice. It takes generally a different method and it relies on legacy modes. A lot of the stuff I want to point out is that the contactless testing stuff has improved really a lot over the last 6 months. So things like the Proxmark 3 is now able to be used with EMV and hopefully adding a bit more fuzzing capability. The Nexus 4, for example, and the latest Android gives a great toolkit for creating test software to actually test out readers, anything that really takes an RFID signal now. As long as it's an ISO one, you can basically throw your cheap Android phone at it and basically look for bugs. So that's pretty much the conclusion. Here is GitHub stuff. I'll publish slides so you guys can read it later. References, and thank you for these people for helping out. Thank you.
Thank you.
What's the worst instance that you've seen?
Oh, worst. Bugger it. I'm not under any NDAs. ANZ Visa cards are terrible. Yeah, I've seen issued credit cards with full names in the track data, which shouldn't have static CVVs. So it's just same as cloning the prepaid one. That's probably the worst I've seen so far, but there's probably really bad ones out there even now, because it depends on the issuer.
Peter, thank you very much.
Thank you.
All right.